Good afternoon. My name is Jeff DeMeyer. I work for American Family Insurance as a software engineer. I've been doing testing for about 10 years. I do some automation. I'm a SME in performance testing and became a SME on service virtualization a few years ago. And what I'm here to talk to you today about is how we've been able to leverage service virtualization in our unit testing part of our software development lifecycle. I've got 45 minutes. I maybe have 30 minutes of material. So at the end of the material, we'll open it up to question and answers at the mic here. And so feel free after the presentation to come up and ask me a question. So this slide here is just, for informational purposes. So the agenda for this presentation is we're going to talk about releasing early and releasing often and how service virtualization can improve that for your organization. We're going to do some talking about what research we did to find out where we had some pains in my organization around software delivery and releasing early and releasing often. What plan that we came up with to implement to try and alleviate these pain points that we identified. Then I'll go over how we executed the plan, the ROI that was returned by the execution of that plan. And then I'll go over some other areas that we've benefited from service virtualization since we first kind of brought it in-house about 3 to 4 years ago. At that point in time, I'll open it up to some questions. So almost all of us have heard this before. All I can tell you at the beginning of this presentation is if you work in an organization that never has any system failures and never has any bugs, then you're not going to get a lot of value from what I'm about to present. The case is, I don't know any organization that doesn't suffer from those issues. So what this is about is, we've always talked about what the true cost of finding bugs early in development is. There's been studies done, IBM I think did the original, and then there's been many studies since then, and they all come up to the same exact conclusion. The earlier you find the bugs, the exponentially cheaper it is to fix them. And plus, from a customer experience perspective, finding bugs in production doesn't help your brand, doesn't help your market, and it doesn't help your sales. So what we want to do is find out how we can test more code earlier when we're given less and less time to develop our apps. In my organization, we've gone from 4-week sprints to 2-week sprints. I'm assuming that most of you in your organizations rarely, if ever, get told that you have more time to deliver a product versus less time. So we have this continuous kind of evolution of developing faster and faster and faster, but yet we're struggling to find out how to get the testing done that needs to get done in the volume that needs to get done and still release on those deliverables on time. So release early, release often. So the point of this whole slide is, and how we got here, is I have to go back a little bit. 2 years ago I did a presentation at this same conference, I think it was on that theater down there, about how we implemented service virtualization in our training environments. And so that was the beginning. We couldn't get it into our developers' hands because with most organizations, the developers are always constrained resources. Nobody wants to give up a developer's time to work on learning service virtualization, because that means that you have to take that developer's time away from another project and your project timeline might be impacted. Most delivery managers, they don't really like that equation. So we started out in training environments almost as a proof of concept. And we got virtualization and backing our training environments. And that was kind of the first thing that we were able to do in the organization to let people know that service virtualization was an option. It was something that worked. It was something that could be delivered. So we started getting this idea of releasing early, releasing often, getting it into our developers' hands. So this is a typical software delivery lifecycle release of code at my organization. I say typical for my organization because we all know in the industry, typical doesn't mean the same thing from one place to the next. So this is our typical software delivery lifecycle. Your code gets checked in, into the dev region repository and deployed to the dev tier. Then typically, there's a set of unit tests run. If the unit tests pass, you might have a smoke test kicked off, either manually or hopefully from some automatic flag that gets tripped and kicks your smoke test off. And then the package is promoted to the integration tier for the next set of testing. The next deployment of the code into the dev tier cannot take place until your current code has been tested and checked in and deployed. Unless you're doing in parallel and you have like code base A, dev tier A, code base B, dev test B, dev tier B, code base C, dev tier C, etc. but now you've got more complexity when you rather probably leave it at one code base. So you can only release as early and as often at the speed of which you can unit test your development code before it goes to gets deployed to prod, or to dev. So what we did after we were able to convince people that service virtualization actually worked in our training environments is we decided to start, kind of seeing in development, if we get the developers to bite on this, if we could get them to use it. There's a story behind this slide about where it hurts, and the story kind of goes with sometimes in organizations, we don't realize that we're hurting. They're doing mocks, they're doing their stubs, they've been doing it that way forever, no problem, right? So it's hard to get people to buy into trying something new when they're not convinced that they're not hurting doing the current thing that they're doing. So our situation had to reach a point where there was visible pain in order to get us onto the next step from to use service virtualization. That pain came about when we decided we wanted to start rolling out to more states. And our rate service, which was something we were unable to virtualize in our training environments because of its complexity, and the people virtualizing it, myself and another individual, we were not developers on Guidewire, which is the insurance application that we use. So we couldn't understand why we would return valid XML responses from a virtual service, but Guidewire would just throw up a service unavailable message, which wasn't true, but that's the message that we got. So we kind of abandoned that for about a year and a half to 2 years, and we had a real rate service in our training environment. And then suddenly this move, as I talked earlier about faster, 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 came up, and the organization said, we want to roll out new products and new rates to all our states, and we want to do it at the speed of light. And the rate service team that creates the rate service and the rate engine was like, we don't have the rates and we don't have the stuff for the new states, and I don't know how we're going to do that. I don't know how we're going to develop against it. I don't know how we're going to test it. Developers aren't going to be able to run unit tests against it to even find out if the system's working. And so one of the individuals from that team, who was a developer on Guidewire and also a developer of our rate service, knew about service virtualization because we went to him from time to time for help with the training environments. And the light goes on, and he goes, hey, maybe service virtualization can solve this pain for us. And within 3 days, after we tried for a number of months, me and the other individual, within 3 days between me and working with a developer who was actually familiar with the system that we were trying to virtualize a response against, we had a fully functional virtual rate service. And the thing that went on is a light that said, wow, that rate service returns a quote really, really fast. Because the rate service used to take 3, 4, maybe even 5 seconds to churn through all the algorithms and spit out a response through the service. That's when we began to identify that there is a hurt in our unit testing, and that hurt is the amount of time it takes. So we met with the developers. The developers identify that a single unit test takes more than 6 hours to complete in its current state. The developers are concerned that as we expand to more states and they're doing more and more testing, they're going to add more and more unit tests, and that the time that it takes to do one build and deploy it into our dev tier was going to just continue to expand. And they were afraid that it would significantly impede their ability to release code at a pace needed to meet their deliverables. So the developers identified that running the unit tests serially, in conjunction with thousands of web service calls being made per cycle, adds significant time to the length of the cycle. And I'll get into the next slides. It shows exactly how much significant time it does add. So the impact of web service calls on one single cycle of the unit test. So there's more than 25 web services being called between these unit tests that they're running. Running, the average response time of a web service, if it's a simple basic web service, maybe you get a second, maybe you get a second and a half, 2, but the rate service being long might be 5, might be 4, but the average was about 2 seconds. They had over 3,000 unit tests, making an average of 5 web service calls per test. That's 15,000 web service calls in one unit test cycle. Total time spent on web service calls was 30,000 seconds, or 8.3 hours being spent just on calling the web services and getting responses from them. So we sat down and we decided to implement a plan to alleviate that pain. The proposed plan was the virtual services, we'd virtualize all the web services, and set the think time to 0, because with service virtualization, you can set a think time to 0, which means every step in the web service model that takes no time whatsoever. It just immediately responds, no waiting. Makes the average response time for most virtual service responses 50 milliseconds or less. Then we would run the unit tests in parallel instead of serially. So instead of running 1 unit test at a time, they would run like 5 at a time. And then a developer or developers would be assigned to the creation and maintenance of these services, rather than what we were doing prior to that was we had a centralized kind of approach to our web services, our virtual services. Which for any of you out there that are looking at service virtualization or looking at implementing it, or even having struggles implementing in your organization, centralizing a central team per se to create virtual services for the rest of the organization is adding a bottleneck when you're actually trying to implement something to alleviate bottlenecks. So it's not a difficult tool to learn. It's very straightforward. It's very easy. And it is much more powerful in the hands of a developer, spending a day or two teaching them how to use it, and then just letting them go to it. The benefits that you get outside of this presentation is, the old way, 5 developers all have a mock or a stub on their local. You can assume that they all have the same mock or stub and it's all using the same data. That's a big assumption. So you might have 5 people doing something slightly different, which is bad, and you also got them going into their code to put this mock or stub, which is invasive to the code. Going into the code to do anything and change it, if you don't have to, is something you should avoid. Using service virtualization as an external call that all the developers can share ensures that they're actually using the same things, that they're actually testing against the same things. So we got a developer assigned to the creation and maintenance of these services that we were going to build for our unit tests. So then we went ahead and executed the plan and reaped an ROI. I'll show you the ROI in a little bit. It's staggering. So the developer spent about 100 hours. I spent maybe 10 with the developer. I helped him build the first couple of virtual services, showed him the ins and outs. He wasn't familiar with the DevTest tool at all, so I also had to kind of get him up to speed on DevTest tool, all of the different options and features available in a web service. In the DevTest web service tool for virtual services, if anybody has that tool and they're using it for performance testing, if they're using it for web services, if they're using it for anything else, everything that's available in those particular parts of the tool are also available in service virtualization. So your virtual service model can call a database, it can read from a spreadsheet, it can parse data, it can filter stuff out, it can drop things into it, you can parameterize, it's all. You've got a request, choose a response, and a response step as the base 3 steps that you need for a virtual service. Anything between the request and the response is available in the tool that's available to any of the other parts of the tool. So you can have a request come in, go into a database based on what's in the request, pull out a row of data, parse that data, put it in property fields, drop it as parameters into an XML response, which kind of gives you the power in a sense like that, where you could have one virtual response that's just an XML with parameterized values, if the signature of that XML doesn't change. And then every time the call comes in, it just looks at what I need to put in the response and drop it in. The presentation before this one was about TDM, and one of the questions at the end of the TDM presentation was, where can TDM and service virtualization be implemented? Where's the best place to integrate those two and work together? And from my experience and my understanding of TDM and my knowledge of service virtualization, having a database and a virtual service model, just a simple database with many columns and tables, that is then used from a TDM perspective for users to go and see what's in there or add stuff in there, and then the virtual service calls what's in there, would allow people to do an insert on a database to add a row of data, to add new things, to request things on the fly, and then have it just drop those values into an XML response. Is that going to work in all cases? No, because some XML responses are very, for some apps they change the signature. You might have 30 lines in one XML and 25 in the next, and that wouldn't work for that case. But if you've got a static XML response, that would work really well. So the developer spent about 2 to 4 hours for each service developing it. That's kind of long on one part. The reason it's long is because some of the services, like the rate service, they take a little bit more time. There are other services out there that you can literally build with service virtualization easily in under 30 minutes, maybe even 15. The developer ran the unit tests in parallel against the dev environment backed by virtual services. And then the unit tests completed in under an hour. So we went from a unit test cycle of 6.5, 7, maybe even 8 hours to under an hour. It says about 50 minutes here. If I remember correctly, the first round was about 49 minutes and 37 seconds. So that's a significant increase in the time it took to get that build out and have 3,000 unit tests run against that build. So here's the service, here's how you reap your ROI on your service virtualization. Based on the things I just went through, this is kind of a breakdown of the math. We took and invested 100 hours of developer time. We saved 7 hours per unit test cycle. So the ROI comes out to about 14.2 cycles or 15 cycles before you actually save the time that it took to build it. So given that increase, we went from 1 cycle a day to 5 cycles a day. The ROI is satisfied in 4 days. Now that's if you're going to do the full 5 cycles or 6 cycles a day, but even if you don't do that many, maybe it takes you 7 days, maybe it takes you 10 days. That's not a long time to reap your value on your investment. In addition, if your sprint length is 2 weeks or 10 days, you go from 10 code releases per sprint if you're able to get 1 done a day, to 50 code releases per sprint. That's an increase of 400% of the amount of builds that you can actually get out in a single sprint, a 2-week sprint. That equates to finding bugs sooner, that's the release early, release often, fixing them earlier, which equates to less expensive fixes. So that's the base part of this. I have a little bit more here about other areas that we benefited from service virtualization in the organization. Places that benefit, our mobile development team just took advantage of, in the latest version of DevTest that we have, you can feed a Swagger doc. If anybody's using Swagger to create their APIs, Swagger doc has the specs, and even though the API might not be ready, might not be implemented, you can feed that Swagger doc into DevTest and it will blow out a virtual service that they can start consuming immediately while they wait for the actual API to become complete. Our training environments, as I mentioned, backed by virtual services, reduce the cost and maintenance of our training environments. I mean, we don't have all the web services that would be maintained on a server, and then the up and down time that goes with it, the unreliability that would go with having a maintenance window during a training class. That doesn't exist at our organization anymore, and hasn't for about 2 years since we implemented that solution. We've used service virtualization to create utilities. So this kind of gets outside of the traditional expected way to use the service virtualization tool, but we've actually had some pretty good success with it. I created a utility, a virtual service that creates virtual services. Because in the virtual service model, you have a virtual service image that, when you think about it traditionally, it's going to send back an XML response. It doesn't have to send back an XML response. It can send back HTML. So now you can give a virtual endpoint that actually returns an end user a GUI to enter data in, hit the button, goes back to the virtual service, parse the values out of the fields they entered, go and run a script, go and do a multitude of different things, and then return a response to that user. So it allows us, in this case, instead of taking a lot of time to build utilities and host them on some web server somewhere, if it's a simple little utility, takes you maybe a half a day to build. Now, I won't say that about the virtual service that builds virtual services. That took me probably 2.5 months. That was actually on a challenge. From coming to this conference 3 years ago, I saw a presentation with my boss at the time that Sprint did, where they kind of created a thing where individuals could easily create virtual services without actually have to use DevTest Workstation. On the flight back to Madison, Wisconsin, my manager says, jokingly, "Do you think you could do something like that?" I'm not a developer, and that's what I've said for years, but I actually am. I've been convinced I'm a developer. I don't know Java. I don't do Java coding or anything else. So I was kind of like, okay, I'll see what I can do. What I did know was service virtualization and the DevTest tool. And once I understood, having done years of testing with the DevTest tool for performance testing, automation, web service testing, knowing that all those functions were available within a virtual service flow, I realized I could present a GUI let the developers put in a couple fields like the location of their XML request response pairs, the name of the service, the port they want to use it on, etc. They click the button, script runs behind the scenes, service image manager I think is the command thing, builds the virtual service, builds the virtual service image. I use a bunch of commands to build all the projects just like you do in dev test when you open up a project. It's got all the same folders, all the same fields, and then deploys it on both of our virtual servers, returns a GUI that tells you what your endpoint is, and shoots you an email telling you what your endpoint is. So that gives you straight up like simple, it's very simple for basic services, but the great thing about it is, it was one of the ways that helped us get in our developers' hands, because the developers, like I said, had not had experience with dev test, and they're super busy, they're constrained all the time. And the last thing they want you to do is put this brand new tool in front of their face and say, I know you're super, super busy, but here. They don't really like that. But when you can go to them and go, I know you're super, super busy, but click this link and fill out those fields and I'll have you a virtual service in under 2 minutes. And then they go, wow, that's cool. And then you kind of got them. It's kind of like the bait. And you go, okay, well, it's super one-for-one, easy to get these request responses, but if you want to make it more complex, now you're going to have to open up dev test, open the project up, and learn the root and the guts of a virtual service. But by then, being able to create a virtual service instead of a mock in 2 minutes, they're 70% sold. And so that is kind of how we got it into the developers' hands, and which eventually led to the unit testing success. Another way we use the virtual service from a UI perspective, I told you that we virtualized all the services in our training environments. One of the other things that our education department came to us with is, they said, we would load up data for the training environment, and the data was burnable. So if you went to class, you would get like trainee 101 and your friend would get trainee 102 as their IDs, because the data that was loaded for trainee 101 and 102 would be, it'd be burned after the scenarios were gone through, because the data would be changed. So we would load up like 5,000 training IDs and all the data that goes with it, all backed by virtual services. And the education department comes back and goes, yeah, we're having a real hard time keeping up with these IDs. We're like, what do you mean? Well, we've got 11 instructors and they all have a copy of the spreadsheet with 5,000 IDs, and every day we have to all contact each other and tell them which ones to cross off because they got used in our class. It's like, so we said, you know what, we know how to do a GUI, we know how to do a UI through service virtualization. Why don't we create a database and put all the IDs in there and create a virtual service for the training department where the students or the people in the class can go into their class, go to this UI, say what class they're checking out an ID for. It goes into the database, grabs the next available ID, marks it as read, sends back a GUI saying, here's your training ID, and sends an email to the instructor saying, this user's got this training ID. There's 5,000 IDs, 4,500 rows into that table. There's logic in the virtual service model that says, when you get to row 4,501, shoot the team that loads this data up for the training environment an email saying they have less than 500 IDs left before they have to reload everything. It completely revolutionized the training environment as far as the instructors are concerned. They're like, oh my God, we don't have to keep up with these IDs in these Excel spreadsheets. It's like, nope, done, taken care of. And then, anybody here use Jira for their defect tracking tool? So, I came to a software engineering team about 4 years ago after having done all this stuff with service virtualization and training. And one of the things that was put on my plate with another friend of mine was administration of Jira. And we would get these emails that would come in and say, hey, I'm so-and-so, I just started work, I need access to Jira. Okay, well, I might be at a meeting, the guy I'm working with might be at a meeting, we might see that email 3-4 hours later, and then it takes us 5 to 10 minutes to manually go in, add his name, add her name, put the email in, whatever, and then send him an email back going, hey, you got added to Jira. Took me about a couple weeks to realize that 90% of every single person we added to Jira had the same exact setup, these same exact security groups. There's a small percentage that were like on secret projects that we still even to this day have to do manually. But I was like, hey, you know what? Why don't I create a virtual service with a UI, again, that you can click off of Jira, and when a little line says, if you need to be added to Jira, click here. They click there. I mean, the UI has 2 fields. Who are you? Who are you trying to add? Could be the same person. You put in the 2 IDs, you hit the next button, 20 seconds or less. You get a response. Here's your user ID. Here's your password to Jira. An email gets shot to you, the person you added, and your manager. So it went from waiting a half a day to maybe a whole day, depending on what's going on, and 5 to 10 minutes of somebody's time to do this remedial work, to let it be a self-service for the users to give themselves access to Jira when they come in. I mean, we have a lot of contract resources, onshore, offshore, come and go and come and go and come and going, right? I think in the 2 years or 3 years that I put this service up, we've probably had 1,500 to 2,000 people add themselves to Jira. I can't even do the math on that to tell you how much time that saved. Letting people do it in 20 seconds versus waiting a half a day, 3 days, 4 days. So there's great benefit from service virtualization when you use it the way it's designed to be used, when you use it creatively, innovatively. One of the things that with the virtual service that creates virtual services, one of the things that also adds as a benefit is if you can convince your organization to use a utility like that, then you have a standardized virtual service model. Every virtual service model created is the same exact standard, same steps, same flow. They can change it afterwards, but everybody's starting from the same thing then. The one that I created in particular has 3 modes of operation. It has a pass-through mode, it has a capture mode, and it has a virtual mode, which is held in an external file. So you can go in an external file and pick the property of mode and say pass-through. And if you've provided an endpoint, all that virtual service will do is pass you through to the live service and take the response and send it back. Why? Why would you do that? Well, because now you can control that entire virtual service mechanism without having to change it in your code, without having to change a property or an endpoint in your code and restart your application because the endpoint you're pointing to is down, right? You now have it all going through this routed virtual service, and you can go out to this external property and go, oh my gosh, the int version of this service is down. We need to get this fixed. I'm going to change the endpoint to dev. So you're changing the endpoint routed through the virtual service rather than changing it in the actual application. The actual application points to the virtual service endpoint. You have complete control now without having to do restarts, without having to do bounces. You also have a way to set up a whole bunch of virtual services and still let people do their development while you're starting to create the nuts and bolts of that virtual service. You're like, okay, I just want you guys all to point to this virtual service endpoint. All these, 27 like in the unit test. I want you to point to all these in your application properties and never change those. We'll change everything in the properties file for these virtual services. What endpoint they go to, what mode of operation those virtual services are in. So you start with the pass-through, you got everything up and working. You then go out to the external property, you change it to capture. What capture does, goes into my virtual service model, has a counter on it that is counting each cycle, it gives a number on the counter, 1, 2, 3, 4, goes to the live service, gets the response, takes the request and the response from that transaction, tags the counter number on the end of them, and puts them in a folder. So now you're actually capturing your request response pairs from a live service. And you're storing them in a folder, which is exactly where you want them if you're going to do the next step, which is I now have all of these real live services that I've captured. I want to virtualize them. Oh my gosh, look at that. They're all numbered and in a folder. All I have to do is go into dev test and say, create a virtual service image out of all the XML request response pairs in that folder. Boom, add it to my virtual service model. Then I do have to redeploy the virtual service model at that time. But after I redeploy it, all I got to do is go change that external property mode to virtual. And now I'm just returning virtual service image stuff. No more calls to the live service. Test it out, make sure it works right. If it doesn't, I go to the mode in the external property file and I go, okay, go back to pass-through. We're gonna try it again, we're gonna figure something out, see what's going on. So every single virtual service model made with that utility is the same now. And it standardized it, and it gives us full control and power over the development, maintenance, changing the complexity, adding all sorts of different things. We've got some virtual services. A couple years ago, somebody created a jar that you can call externally a spreadsheet and treat it like a database. So what that's allowed you to do is, coming back to kind of the TDM thing earlier, if you've got a virtual service and all the data that the virtual service is consuming is in an external Excel spreadsheet that can be queried like a database because of the jar that CA provided from one of their customers. I don't remember who it was. So in that virtual service model, you go, hey, I query this Excel spreadsheet for this data, bring back all the values, drop it in this XML response. I have a new test scenario. What do I do as a user? I go out and I add another row of data to the spreadsheet, and I've got it in my virtual service. So that pretty much sums up all of the stuff. And as I figured, I've got about 15 minutes left, so I had about 30 minutes of data. If you have any questions, please come up to the mic. The session's being recorded, so we'll get it all on tape, and the whole world will be able to see it. So if you want to be a celebrity, the microphone's right there. Any questions at all? No question. Well, if there's no questions, I'll also be available over here for a little while after the presentation. And I hope the information I provided here today will help bring value to your organization if you're still using, if you're using service virtualization. I hope I've given you some ideas of how you can actually leverage it more. If you're thinking about service virtualization, I hope that you see that there's tremendous potential with the tool. And if you're trying to get it, if you have it and you're trying to get it implemented in your organization, the one final thing I can leave you with is you really, really need to get this tool in the hands of your developers. That's where it is the most powerful. The name of the tool is DevTest. We brought it in as a testing tool, so part of our struggle was people thought it was a test tool and not a development tool. Particularly the developers are like, no, I don't want to use DevTest, that's a tester's tool. It's not. It has so much power in the hands of developers that it can save you lots of heartache and a lot of pain. All right, no questions? Then we're done. Thank you.